Hi everyone, thank you for joining me again in the next session. And now we're going to be dealing with grade 11 math. So as you can see, grade 11 math is a review somewhat of grade 9. So in grade 9 we started with the different types of numbers and the radicals of the numbers. So now we're going to go into unit 1, which is numbers and radical, and this is just a review, as I said, of grade 9. So natural numbers, we did that in grade 9. It's denoted by an n, and it starts with 1 and it continues to infinity. Whole numbers starts with 0 and it's denoted by a w, continues from 0 onward to infinity. Integers, it's denoted by an I. It starts from infinity, hence the 3 dots on this side, and it's going towards the right on that side. So it starts in the negative, goes to 0, then it goes onward in the positive direction. And rational numbers, we are able to define that they are all of these numbers. So whether it's 1, 2, 3, 0, negative, all of those are rational numbers. Plus any fraction where b is not equal to 0. So you know that if b is equal to 0, then this number is not identifiable. Okay, so it's not possible to divide by a 0. So any number where a is any of these or b is any of these except 0. So in a whole number section, we won't use a 0 where b is equal to 0. Okay, and then we can see these examples here. What would be qualified as a rational number? 0.5, 1.24, 2 over 5, negative 1 and a quarter. So those are just a review of what we did in grade 9. And then this number line here is just a form of having a visual of where the numbers are placed on the 9. So we already know that the number line, again, it looks like the integers, right? Where you have negatives on the left, positive on the right. And in between, we can identify some of these numbers. So if you notice on this side, between the 6 and the 7 is where we have negative 6.1. We want to put it here. And the square root of 5, and you notice this, we don't have the negative inside the square root because you cannot have a square root of a negative number. So it has to be on the outside. So whatever that value is, that number is negative once you find the square root of that number. And 1.4 is in between here, and 3 and 3 over 5 is here. So it's closer to 4. Again, in terms of what we talked about in the previous session for grade 9, we talked about how these numbers are related. All rational numbers are natural numbers, right? All integers are whole number and natural numbers. All whole numbers are natural numbers. So if you go up again, natural numbers would be part of the whole numbers. Whole numbers and natural numbers would be part of the integers. And integers, whole numbers, and natural numbers are all part of rational numbers. So that's how you eyeball it. Okay, so we're going to move on. We're going to talk about powers and roots. Since you already know what this is, we're just going to go into powers and roots. And this is just going to be a quick review so that you can have an idea of what to expect in grade 11. Okay? So let's move that along. So unit 2, we're talking about powers. And this is unit 1.2, sorry. We're still in unit 1. And roots of numbers. Okay? So let's think of the base, right? So we have a base. So any number that has a base will be the bigger number at the bottom. So this, we will call it the base. So that would be the base. And here, say that will be at the top. We call that the power. So we're raising it to the power of 3. And simply said, it's just 5 times itself 3 times. I know some people make a mistake and say it's 5 times 3. That's incorrect. It's 5 times 5 times 5, and we know 5 times 5 times 5 is 125. So if we raise this 5 to the power of 3, it comes to 125. So let's understand what a root of a number is. So this is the power. So this is what we're talking about, power. Now the root, which is the next portion, is the opposite of having a base number raised to the power of whatever number is here. It's basically finding out how many times that number could be declined, which means it's the same, it's the opposite of what we just said. So if we have 125 and we want to decline it 3 times, so that's a cube. The answer will be the opposite, which is 5. And it's just the simple math. And this application is called finding the root. Okay? So that's how you find the root. The root is the opposite of raising the power. So normally we would say this is also raised to the power, but we have another way of saying it. So this is called a cube root because it's 3. So we call that a cube root. And if we had 25 here, there's an imaginary 2 here, and without that we understand it's 2. This is called the square root. So this is normally a square, and we call that the square root. And we know that that would mean we're declining the number twice. And it's a number that was multiplied by itself that gave you the 25. So therefore, you're finding the base number that would be multiplied by itself to get that number inside. So now we know the answer is 5. Okay? And if you were to go over here and you're finding the square, which is the opposite of square root, it will be 5 times 5. Again, it's the same number multiplied by itself, which would be equal to 25. So you can see the opposite. So over this side, we have the power. And over that side, we have the root. Okay? So powers and roots. So if we were to label them, this is what it would look like. So if we were to label what all of this means, so we have A, which is just a random number, whatever the base is. we'll call that the radicand. Radicand. We'll call this, which is the sign of the root that tells you what you're doing with the number, that's called the radical sign. It tells you what you're going to be doing with that number. And then here is what we call n, which is called the index. This is what tells you how many times you're going to be reducing that number. So in this case, as we said, if it was 125 and this was 3, you know that we're reducing it 3 times, and then the answer would be 5. And of course, you can do that with a calculator as well, but this is just to understand why. One of the things I try to, when I'm teaching, I teach the why so you understand why. I don't just teach you the information, because if you just learn the information, you never understand why, and you will naturally forget what you're doing. You'll just try to memorize. I don't teach memorization. I teach understanding, and I teach trying to apply your understanding to what you're being told to find in your questions. So here we have an example, 64. And if you know your times table, you'll notice that a lot of your multiplication, from your multiplication table, you'll have all of those numbers multiplied by itself. 5 times 5, you have 2 times 2, 8 times 8, 9 times 9. All of these will be applied here. So if you know it, you don't even need to use a calculator or trying to figure it out. You know already that 8 times 8 is 64, and it's the same number multiplied by itself, which means the answer is 8. Okay? So in this case, what we can say is that we can identify what the different parts of this expression is. So the radicand is equal to 64. And we can say the index is obvious, which is equal to 2. Okay, which is this. That's the index, and this is the radicand. And that's much as we can talk about in terms of square root and powers. Again, do not confuse powers with multiplying that number by the index. Whatever the index is, you're going to use that number as the power. Okay? Okay. So we could do a few, and we'll just practice just a few. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if we were to find the square root of 121, again, there's an imaginary 2 here. We already know what that is, because if you know your times table, you know that the answer is 11. Number 2, so we have 3 here. Eight over 27. So what is a cube of 8? So in this case, we do each part separately. So we're gonna do the numerator separately and the denominator separately. So we know that there's something that was multiplied 3 times to get 8. And what do you think? You probably could start with 2. Let's see if that works. 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So the base number would have been 2. And then 27. What do you think it is? 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is equal to 27. So the base would have been 3. So the answer is 2 over 3. Okay, this is just for explanation purposes. And what about 3 to the power of 4? Again, you know that 4 is a power, so you just simply write it 4 times. Okay? And then we're going to multiply it 4 times. So 3 times 3 is 9. 9 times 3 is 27. So you can do 27 times 3. 3 7 is 21. 3 2 6, 7 8. So the answer is 81. Okay? And then we have the square root of 16. And it's just an imaginary 2 there. Again, if you know your times table, you'll know that the base number is 4, because 4 times 4 is equal to 16. So we won't do any more because you pretty much got the picture. So you got the square, which is the easiest one, and raising the power to the power of whatever number you have here. You just need to write that number 4 times to make sure that you get the understanding of it. Okay? So let's just give you a summary of ideas. This is just for understanding how the numbers are applied. And the importance of this lesson is to make sure that you remember how to do these questions. So since 36 is shown as 6 to the power of 2, then the second root of 36 is 6. Okay? So we're going to say since 36 is shown as 6 to the power of 2, then the second root of 36 is 6. Therefore, the square root of 36 is equal to 6 times 6, which means it's equal to 6. Okay? I hope that's clear. So this is just moving from squares to square root, just to understand the connection, because it is connected. Same thing for this one. Since I have to change my markers because somehow they're not as good as I thought they would be. So 125, no, that's better, is, we talked about this in the first page. Okay? The second root, the third root, sorry, So this is 3. Of 125 is 5. So therefore, the cube root, which is 3 here, is equal to, you guess it right, the base. 5 times 5 times 5, which is equal to 5. Okay? 32 is 2 to the power of 5. Therefore, the fifth root of 32 is 2. And do you see the connection? So this is the base. This is the power, right? And the power, opposite of power is the root. And the base will be the answer that you're getting once you find the root. Therefore, if we put the 5 here, which is the opposite of what we just did, of 32, that's equal to 2 times, so we're just going to do it 5 times, and that's equal to 2. Okay? One more. Easy. 16. 2 to the power of 4. And this is also something that it's easy to remember. Like if you are used to doing it so many times, it's not hard to remember. Is 2. Again, it's the same principle. And if you got the answer for this one, square root of 16 is simply 2 4 times. And the answer is 2. So you see the connection. So you'll understand you can go from the number to expressing it as a power of a base. Then you figure out what the root will be based on applying it in the opposite direction. And that's basically what that is. So if you learn this, you'll understand the connection between roots and powers. So powers over here and roots over there. So I'll give you some to try on your own, and then you can put it in the chat. This one is harder to erase. I'm going to give you some hard ones. So 1, 2, 3, 4, 5, 6. Okay? I'm going to use that as a cube. So here we have the cube root of 27, cube of 4 over 9, the cube of 625, and I know I write the 4 a little bit low, but it's really up here, just so there's no misunderstanding. Cube of 4 over 121, the cube of 3, 0.375 and the cube of 0.0032. I notice I don't say 32. A lot of people make that mistake. Once it's behind the zero or the point, you don't say 32, you say 0032. You count it out because it's no longer a 30. It's 32. Another thing, regardless of whether there's decimal, you have to use the same principle. So another way, yeah, you just have to use the same principle as though, pretend that this is 32. And we did that in the other section. So pretend this is 32, and then you find the root. Okay? And again, you pretend that this is 3,375. Then you find a root. And when you're done, you make sure you move the answer 4 decimal places. Okay? So move 4 decimal places. So I'll give you a hint. If I had something like this, right? So you know when you're multiplying, so already I know that the square root of 25 is 5, right? So I just need to figure out what will make it happen. So simply put, it would just be okay. Oh, I missed a 0. Sorry. I missed a 0. My apologies. So it would be 0, 0, 2, 5. But if you remember your math, it will be 0.05. And the reason is, I'll tell you why. Remember your math that whenever you're multiplying a number by a decimal, the amount of decimal that you have here, so we have 1, 2, 3, 4. That's the reason why it's 4 decimal places. So if I were to multiply this by itself, I won't go over to the right or left, because that will give me a whole number, and because a decimal is multiplied by itself, so this is what I would have to do. I'm just reminding you. So it would be like this. 5 times 5 is, so I need 4 decimal places. Okay, that's how I would have to do it. So let me bring it up so you can see what I'm talking about. So example, and this is a review. When we're multiplying decimals, we always need 4 decimal place in the first stage. And then the second stage, we will have 3 decimal places. And nothing will be here. Okay? So I can just put an X. Okay? So I would say 5 times 5 is 25. 5 times 0 is 0 and then 2. Then I will fill it up with this space. Okay? Five times 5. Oh, so now we get, so now we have already multiplied the 5. Now it's time to multiply the 0. So we're going to have 0, 0, 0, because 0 times everything is 0. So now we're going to add. And that's the reason why, this was when we multiply, right? That's the reason why the square root of 0.0025 is equal to 0.05. Okay? So you can work on that and ensure that you have the right answer. And see what I said here. So my apologies. It's not automatic. You have to find a number that can multiply by itself, but you have to also find the right. So you can even do a square root or a cube of this number, but make sure you understand the principle. Okay? A number that is the base of that number multiplied 3 times will give you 3.375. Okay? And this is why the rules, you have to maintain the same rule you learned before. You can't forget it. So at grade 11, you should be remembering what you did in grade 9. Remember what you did in grade 10. Otherwise, you're going to be lost. So we're going to go to another section. Let's see what we have today. So we're going to talk about ordering radicals. So this is 1.3. So we're going to figure out how to order radicals. So once you do those other questions, then you'll kind of figure it out. And in this case, you can use a calculator. Okay? The previous lesson was just to give you an understanding of how to identify the square roots and the squares, but you are allowed to use a calculator. So let's put these numbers in order. So we're gonna figure out how we place these numbers on the number line. So we know the square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 16 is equal to 4. The square root of 25 is equal to 5. And the square root of 36 is equal to 6. Okay. So we know this. We know this already. But let's look at another way to express other numbers that are not in this list. For example, 1. We know that 1 is greater than, or less than, sorry. Remember, this is less than. So the dog is eating the the greater portion. So the mouth is open to the greater portion. Okay? I'm not sure what other people say, but that's what I say. Okay? And the reason why we're saying that the square root of 3 is bigger than 1, but is less than 2 is because when we look here, this is how we know. Okay? Because if you see, square root of 1 is 1, and the square root of 4 is 2. So if the square root of 1 is 1 and the square root of 4 is 2, then this area here must be true. The square root of 3 is less than 2. It's in between the two. Okay? And I can just write it down. Because, this is correct, because the square root of 1 is less than the square root of 3, which is less than the square root of 4. Okay? Again, we can do the same thing. So this is just another example. We can say 5 is greater than square root of 30, which is also greater than 6. And if we look here, we found that because the square root of 25 is smaller than the square root of 30, which is smaller than the square root of 36. As you can see, the number is increasing that way. Same for here, right? So this is just the square root of the numbers here. So let's talk about cube. Okay? So once you write that down, then you can, and this, the purpose of this is to lead you somewhere. Okay? You're on a journey and you need to get there. So in order to get there, this is how to get there. So we're going to write all the cubes. Okay? So cube 1 is equal to 1. Cube of 8 is equal to 2, because 2 times 2 times 2, 3 times is equal to 8. Square root of, cube root of 27 is equal to 3. The cube root of 64 is equal to 4. And the cube root, and we did that a few times, is equal to 5. Okay? So what does that mean? It means that if we have 1 here, okay? So example. So this is just examples, okay? So if we have 1 here, that will be less than the cube root of 5. Because you know where that lies? In between these two. Okay? Which is smaller than 2. Because we're in between here. Similarly, example number 2, the square root, or cube, I must say. Before I get to that, I'll say 4 is smaller than the cube root of, let's say, 100. Okay? Which is also smaller than the cube root of 125. Which is actually, you don't need to put that, you just put 5 because we know that that's what this is. Okay? So the same applies for cube as it applied for the squares. And you can also place this on a number line. We didn't do it for the first one, but we can do it for this one. So this is example 1, and this is example 2. So let's put this on a number line. Okay. So we don't need to use this side, really. We don't need to use that side because we're talking about cube of numbers. So if I were to locate this number, it will be between 1 and 2. So it will be here. We don't know what it is, but we know that it's there because it's in between 1 and 2. And this cube of 100, we know it's between 4 and 5. Okay, so this is just a picture, a synopsis of how to identify numbers that you cannot define just by doing a root or a cube, but you can identify them on the number line. Okay, so let's do a little bit of review. So this one is pretty easy. So we're gonna order So we're going to order the following radicals from smallest to largest. Okay? Okay? Smallest to largest. Again, these are all practice. So 1, okay? And let me know how you do with those. So you can just write that down for me. And if you want, you can finish them in the chat. Once you put it in the chat, then I will take a look. Okay? And you can use the same principle, what I used before. You can go back to what we talked about. You can use a number line. Okay? Okay, Okay, you can use a number line, you can use a calculator, or you can just you can figure it out based on the squares or the square roots. And I know some people don't say square root, but you can just say roots, okay? So I think I'm going to do one more unit to finish it off, and that will be simplifying radicals by factoring. Or perhaps I should leave it to this point because I don't want to. I think we're going to stop here for now just to digest all this, because when we go into factoring, we're going to use unknown numbers, which are variables. So we don't want to get into that right now. So I think we'll stop for now with this information. And then once you digest all this that we have talked about for units 1.1, 1.2, and 1.3, then we can go into the other section, because I don't want the video to get too long and for you to be overwhelmed. Okay, so that's it for tonight, and thank you so much for joining me. Have a wonderful, wonderful rest of your day. Bye.